I'm Ylleniza Ysabela Dizon, and in this video, I'm going to do an example problem on calculating the average normal stress on an axially loaded member. On this problem about axially loaded member, we are given a rod where segment AB is 20 mm in diameter and segment BC is 50 mm in diameter. External loads are applied outside. 5 kilonewtons at point A, pointing to the right, and 20 kilonewtons at point B, pointing to the left. The given rods are fixed about NC. So looking at the rods, we are going to cut between these concentrated loads and discontinuities. So we're going to make a cut here between A and B, and here between B and C. We're going to draw the axial force diagram and then calculate the average normal stress in segment A, B, and BC. So now we're going to calculate the internal loads. Here at segment AB, we have 5 kilonewtons going to the left. Moment and shear force is equal to 0, where we have only the normal force as a non-zero variable. To calculate this, we need to get the sum of the forces equal to 0, where NAB plus 5 kilonewtons is equal to 0. Solving this, we're going to get NAB equals negative 5 kilonewtons. It means that the force should be going to the other way, thus compression in segment AB. Now, if we look at segment BC, where we have 5 kilonewtons to the right and 20 kilonewtons to the left. Just like in segment AB, only the normal force is a non-zero variable. Doing the same process, we need to get the sum of the forces equal to 0, where NBC minus 20 kilonewtons plus 5 kilonewtons is equal to 0. Solving this, we get NBC is equal to positive 15 kilonewtons. NBC is positive, meaning the normal force BC is causing tension in segment BC. So on the next part, we're going to draw the axial force diagram, or what we can also call the internal normal force diagram. So now we know that we have 5 kilonewtons in segment AB, which we're going to put here. And in BC, we have 20 kilonewtons going to the left and 5 kilonewtons going to the right, which is like 20 kilonewtons minus 5 is positive 15, which we're going to put here. So we're going to form a graph like this. So we know that the reaction right here is 15 kilonewtons going to the right. And this is the internal axial force diagram for the given problem. So for B, we're going to calculate the average normal stress in segment AB and segment BC, where sigma is equal to N divided by the cross-sectional area. So in segment AB, we get the cross-sectional area AB equal to pi over 4 times the diameter AB squared, which is equal to pi over 4 times 20 millimeters squared. Solving that, we get 314.16 millimeters squared. In segment BC, we have the cross-sectional area of BC equal to pi over 4 times the diameter BC squared, equal to pi over 4 times 50 millimeters squared, and solving that, we get 1963.50 millimeters squared. So now that we have the cross-sectional areas of segment AB and BC, we can solve for sigma AB and sigma BC. Sigma AB is equal to negative 5 kilonewtons over 314.16 millimeters squared, equal to negative 0.01592 kilonewtons over millimeter squared. So kilonewtons over millimeter squared is also known as gigapascal. Moving on, we have sigma BC equal to 15 kilonewtons over 1963.50 millimeters squared equals to 0.00764 GPa, or kilonewtons over millimeter squared. Now, going back to the problem, we have drawn the actual force diagram and calculated the average normal stress in segment AB and BC. The average normal stress in segment AB is negative 0.01592 gigapascal, and the average normal stress in segment BC is 0.00764 gigapascals. And we're done! I hope you learned something. Thank you and God bless.